Hello everyone. This is the last video of the video series about feature engineering techniques, and I will briefly explain the feature learning, the last technique, and then I will conclude this video series with a summary. Okay, let's start. Feature learning is different from the previous techniques. If you remember the machine learning pipeline, after understanding the problem and the data and exploratory data analysis steps, we can apply some feature engineering techniques before training our machine learning model. So all of those techniques, feature improvement, feature construction, feature selection, and extraction, are designed by us, by human, and also implemented by us. But in feature learning, the feature learning process is automated process, and the feature learning will be handled by deep learning models, the artificial neural network architecture. That is the biggest difference. And it can be carried out by supervised, unsupervised, or semi-supervised learning. There are different types. And the biggest advantage over the traditional machine learning methods, machine learning techniques, the features will be learned by the model. Therefore, our bias, human bias, will not be transmitted to the model. So the models will be more robust against feature bias. If you want to learn more about the details, the technical details, I added a link to the notebook, and also this notebook is available in the description. You can check this paper. But briefly, we can say that the objective is collect the most important, the characteristic features of the input before making some predictions, some classifications. Here, there is another important survey paper about the feature learning and the deep learning architecture. So if you want to understand the big picture, you can also check this paper. Let me give you an example. So it will be more clear. So here you can see the input. The input is an image. And with traditional methods, extracting the features is quite difficult and expensive. You can define a lot of features to capture some important characteristics, but it will not be a feasible solution. If you are familiar with the CNN, convolutional neural network architecture, you can easily understand it. So this is a supervised feature learning process. So each image has a label, and when we provide more images, our model will learn the characteristic features of this class, this label. And during the training progress, model will adjust the values of the filters. Then those filters will be used to capture the most characteristic features. For example, that filter can be used to capture the corners. For example, with this filter, model can capture the insertion areas of the human body. So let me show the CNN architecture, the convolutional neural network. We have an image, we have some convolution and pooling layers. Inside the convolution layers, we have filters, and this process is called as feature learning because image will be transmitted to the next layers, and the most important features will be learned and extracted by this part before fully connected layer. In other words, the classified parts of the CNN architecture. As you see, we will not define anything, but the model itself will extract these features by the convolution and pooling layers. Okay, as a conclusion, we can say that we have 5 feature engineering techniques, and the first 4 techniques, which are feature improvement, construction, selection, and extraction, these are designed and performed by the humans, and the last one, feature learning, is performed by the deep learning model, for example, CNN model. And if you look at all of them, feature improvement is crucial to improve the performance of the model because we are increasing the contribution of the existing features, for example, by handling with the missing values or scaling them, normalization, or dealing with the outliers. We are not changing the features interpretability, but we are improving the contribution of existing features. Second one, feature construction. With feature construction, we are changing the interpretability of the features. So we can use existing features or we can use some additional sources, but at the end, we are adding new features. For example, you can have salary as a numerical feature. Then you can construct income status based on the salary, but instead of numerical, you can have categorical like low, medium, high. So you are changing the interpretability of the feature. Or you can use 2 features and then you can construct one feature, the height and weight, and then body mass index, BMI. And the number 3, feature selection. This is also critical technique to increase the performance of the model, because with feature selection we are selecting the optimal subset from our feature set, and this will increase the model's performance. For example, if it's a classification model, you can increase the classification metrics like accuracy, precision, recall, and you can decrease the total cost, because instead of having, for example, 100 features, maybe you can just use 30 features. Even if you have the same result, same classification scores, if you are doing with less features, this is also good, because we know that each dimension, each feature cause a cost, a computational cost for us. We have a lot of methods under the feature selection, and the most common ones are this filter, wrapper, and embedded techniques, but also, of course, you can see a lot of other techniques, for example, genetic algorithm-based feature selection. And in feature extraction, we have raw data as input, for example, image or text. Then we are extracting features, some techniques like vectorizer or PCA, principal component analysis. Then we are creating the features. In the vectorizer, you can use text. Then with count vectorizer, for example, you can have numerical representation of the data, so you can feed the model, you can train the machine learning model. Because we know that machine learning model cannot be trained by raw data like image or text. Or you can have some features, for example, you can have 1000 features, 1000 dimensions, and you can apply principal component analysis, and for example, you can have maybe just 10 principal component analysis, and you can decrease the cost a lot. And the last one, feature learning, as I said, instead of us, the model, deep learning model, will extract the features automatically, and those extracted features will be used to make some classification, for example, in the CNN architecture. Okay, that's the end of the feature engineering video series. I hope this guide will be beneficial for you, especially at the beginning. At the beginning of the machine learning journey, these terms can be a bit confusing, so I tried to clarify those terms and explain them with a brief explanation. And of course, this is a guide for the beginners. If you want to learn more, if you want to go deeper, you can check the papers, you can check the literature and the existing books. For example, Feature Engineering Bootcamp is a good source, you can check it. And of course, according to your problem and domain, you can go deeper with the right literature review. Thank you for the watching, and see you in the other videos.